So hello guys, welcome back to the channel. So in today's video, we're gonna solve the problem number 125 and the problem name is valid palindrome. So first of all, what is a palindrome? I would say this thing over here. Palindrome is something similar to reversing a string. Let's delete this one. A valid palindrome is basically something like this. And when you reverse this, it's gonna be mam as well, right? MAM, MAM. Keep it double A as well. It's gonna be the same, right? So even though you reverse it, it becomes the same. It is exactly the same, right? M comes over here, AAM. So this is a palindrome string. So let's understand the problem first. A phrase is a palindrome after if after converting all the uppercase letters into lowercase letters, all uppercase should be converted to lowercase. Okay. Converting all uppercase letters into lowercase letters. Okay, removing all alphanumeric characters. We have to remove all the alphanumeric characters now. We have to remove all the alphanumeric characters and it reads the same forward and backward. It reads the same, that is the same thing, right? Forward and backward. Alphanumeric characters include letters and numbers, just letters and numbers. It can be like this as well. Okay. So this is the problem. We have to simply do this. You look at this: a man, a plane, a canal, Panama, right? And you remove the semicolons, the spaces, the commas. And you remove all this. And when you remove all this, you're gonna get a text over here, which is gonna be removed. Okay. So let's start from scratch. Just submitted the code. Okay. So let's start from scratch again. I'm making the videos right now after solving the problem. So So this is the question. We have to get this, okay? So there are majorly three major ways in which we can solve the problem. So first one, let's do it by the first step. So this is the problem over here, okay? And so we have the string s, right? We have the string s. So what I'm gonna do is let's store it and what I would say is an variable, okay? The s is the input over here. So I've taken the s and we're gonna store it over here with the help of s.lower function provided by Python, which is gonna lowercase all the characters. Okay, so lowercase is now done, converting all uppercase into lowercase. So first step of the problem is done. We have stored it, removing all non-alphanumeric characters. Okay, we have to remove all alphanumeric characters. So let's make this variable as clean text is equals to, we're gonna iterate through each and every character of the string. For that, leave the join method and char. We're gonna return the char for char and lowercase. For each char, for each character in the lowercase string, which is this one, okay, we're gonna return the char. The same character is gonna be returned. If it is only gonna be returned if character is alphanumeric, no special characters are involved. Okay. So what we are doing over here is we have taken this over here in lowercase. This is gonna be the whole string, okay? This is gonna be the whole string for each character in lowercase, for each character in lowercase. we're gonna return the char, and each character is gonna be joined by without any spaces, and it is only gonna be joined, or it is gonna be only returned, that is by if character is alphanumeric. We have to have the character as alphanumeric, or nothing is gonna be returned. So we are basically cleaning the text. Now that thing is done. Alphanumeric characters include just letters and numbers. Remove all alpha. The second and third step of the problem is done, but we need to reverse this as well, right? We're gonna use a very smart function over here, very smart method, I would say, is equals to clean the text, add the square brackets, and this is gonna reverse it. Okay, so clean text reversed is equals to clean text, whatever the output is gonna be here from here is gonna be stored, whatever the output is gonna be here is gonna be reversed and is gonna be stored in the clean text underscore reversed. Okay, now if clean underscore text is equals to clean underscore text is equal to reversed, we're gonna return true, else we're gonna return false. This is the first type, and this is the easiest way, I would say, but it is lengthy, so we're gonna optimize it as well. Let's just run it. Just a second. We have a problem over here. Okay, the function name is wrong. Alphanumeric. Okay. Case 1, case 2, case 3 accepted. Now if you copy this and if you paste it over here, let's calculate the time and space complexity. It's O(n) and it's O(n) again, are linear. Okay. Now this was one way. Now the second way, let's make the what I would say is the program smaller, and it is gonna be in a much more efficient way as well. So let's delete everything. Now we're gonna make a new string over here, which is gonna be an empty string first of all, cause we store that, right? So for C and what I would say for char and S, let's follow the same what I would say same variables or the same temporary variable names which we have used earlier. So new string is gonna be empty for char in S. We're gonna say S is the string over here, okay? S is the string for character. For each and every character in the string, we're gonna iterate through each and every character in the string. If C is alphanumeric, we're gonna do something over here. That is, we're gonna take the empty string over here and we're gonna add those elements C dot lower. I'll explain that to you what is happening over here. Okay, new string is empty. S is the input string, okay, for character, for each and every character in the string. If this is the string, for each and every character, A space MAN, for each and every character in the string, FC, we're gonna replace it with char. If character is alphanumeric, if character is alphanumeric, then we're gonna perform some operations. If it is not alphanumeric, then we're gonna skip the part. Okay. If character is alphanumeric, we're gonna take this empty string over here. From here, and we're gonna add those elements char, and it's gonna be added with the help of the lowering function. We're gonna add one after lowering after lowering that particular character. We're gonna lower that particular character, then add it to the string if and only if the string or the character is alphanumeric. Okay, now let's go a bit back. Now we're gonna return the new string is equals to. Now since we have just did all the operations, alphanumeric check has been done, we have lowered it, now we need to reverse it, right? So now we got, what we're gonna do is we're gonna just pass in through boolean thing over here. Okay, so return the new string. We're gonna return true if the new string, which is over here, the new string whatever we get over here is equal to the reverse of the new string. This is gonna reverse it, right? So if it is right, then we're gonna return true. If it is not right, we're gonna return false. Let's run our code. Okay, we need a double. Let's copy this. Okay, character is alphanumeric. Okay, that is the function name, right? We did the same mistake in the last code as well. Character is alphanumeric. Now it should run, I think. The case 1, case 2, case 3 has been satisfied. That's what we wanted, right? Now let's check out the space and the time complexity over here. Now let's calculate this. The overall time complexity remains O(n). The space complexity is O(n). This is due to the creation of the new string. We are creating the new str over here, which is the worst case. Could be as long as the original string is if all characters are alphanumeric. The new string, the reversal function, whatever you are doing over here is also contributing to space. Therefore, the total auxiliary space used is proportional to the length of the input string, resulting in O(n) space complexity. Okay. So what if you want to make it a lot better? We're gonna use two pointers. That's where two pointers comes into play. All these things are easy, right? Now we need to go onto a whiteboard. Okay, so let's go over here, and I will make a simple array over here. Okay, a simple array. Okay, let's make it so you can understand it in a much better way. Okay, line. Give me a minute. Uh, okay, so this is the array over here. Oh, this is the string over here. Why I'm saying array. I'm adding those lines. Okay, for your understanding, let's add those lines so you can understand it in a lot better or a much better way. Okay. So let's say we have added what I can say over here is don't want to add much to it. Okay, let's skip this part. Okay. I'll just explain that to you in the code because we won't be able to get it. It is gonna take a lot more time comparatively. Okay. I'll just go onto the whiteboard when you do and some things pop up. Okay. So Firstly, two pointers, right? So a straight line, the first pointer, okay, the first pointer and the second pointer. First pointer is over here, second pointer is here. Okay. So left comma right is equals to 0 and right is gonna be length of the string minus 1. That you know, right? Left is equals to 0 and right is equals to length of s minus 1. Since we start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's an extra number over here. So you want to cancel out that last digit since we're starting from 0, but the length always starts from 1, right? So we want to cancel that last digit. So we have declared the pointers. Now we're going to go inside a while loop. While left is less than the right. Okay. While the left pointer is less than the right, we're going to keep incrementing. Okay. We're going to, how do we take that over here? We're going to keep incrementing it. Keep incrementing the left pointer towards, we're going to keep incrementing the left pointer and we're going to keep decrementing the right pointer. Okay. Until and unless we get that it should not be equal in short. Okay. It should not be equal. I'll just add the point over here, right? So let's say this comes over here and this comes over here. Since each and everything is done, each and every test is performed, we're gonna break out of the statement. Okay. So 1, 2, 3. And okay, let's start. Okay. So while left is less than the right, we're gonna do something. What are you gonna do? We're gonna do again a check while left is greater, while left is smaller than the right, and not s dot s of left is alphanumeric. S alpha numeric. We're gonna increment the pointer. So let me explain the code to you. While left is smaller than the right and not left, if left is alphanumeric and we have added the not over here. If left is not alphanumeric, we're gonna increment it. Okay. If we get alphanumeric over here, let's say we are over here, so we have to increase it, right? Here is the comma. We have to increase it. We have to take it to the right. Okay. And to take the left pointer to the right. And again, we're gonna do the same. While left is smaller than the right, the same condition, and not s of right. So basically what we are doing is any other thing rather than alphabets and numerics or digits, we gonna skip that particular character and we're gonna move on to the next element or the next character in the string. As simple as that. Okay. That is what exactly this line of code or this line of code is doing. And s of right is alphanumeric. We're gonna do right minus is equals to 1. Okay. So we have done the part over here. Converting all upper cases into lower cases is not done. Removing all alphanumeric characters, we have implemented that logic. With the help of that, the second and the third part is done. We need to do the first part. But there might come a condition where left is greater than is equals to right. If that happens, if this moves towards here, if both of them point at the same text or the same thing over here, then we have to, what we have to do, if left, then the condition is satisfied, right? But left is greater than the right. By left is greater or equals to right, we have to break out of it. And that condition, we're going to implement it at the last. Okay. Don't worry. Explain that. Explain the whole code to you again. Okay. If you're not getting it. If S of left dot lower is not equals to S of right dot lower. We're going to return false. And the final one, that we have to increment the left pointer by 1 and the right pointer by -1. That is, we have to decrement it. Okay. Now, so we are breaking out of this, right? We are breaking out of this. So once we break out of this, we want to add return true. I'll explain the code to you. I know you're not getting it. Some of you guys are not getting it. I'll explain that to you. Okay. Surely explain you. So firstly, let's go on to the first line. What's happening over here? Class solution, as simple as that. Then we define a method as palindrome, self, string, and boolean. This is given to us to check if the string is palindrome or not. Now we're gonna initialize the 2 pointers, which is left and right. Left is at the beginning of the string, and the right is at the end of the string index. That is the length of s minus 1. Now we're gonna enter a while loop. While that The while loop is gonna keep running until and unless left is less than the right. The loop processes from both the ends. Okay, the loop process from both the ends. That is, the loop process from here until here. Cool. Right. Now inside the loop, what we are doing is we are doing basically two while loops again, two if statements again, and we're gonna keep moving the left pointer. That is over here. We're gonna keep moving the left pointer ahead. That is, if we encounter a non-alphanumeric character. Non-alphanumeric character, if we encounter that, then we're gonna increase the left pointer. If we encounter this commas over here, this commas, then we're gonna increase the left pointer, but the right pointer is gonna stay over there because we need to compare that element, right? And we are removing those spaces. And while we are gonna do the same condition, while left is less than the right and not of s of right is alphanumeric, the right is gonna be decremented. Understood? This part is understood, I think. Now, while left, not while, if both of them go at the same place or is equals to, or the left passes the right, okay, left is bigger than the right, or left is equals to right, we're gonna break out of the statement. That is, we're gonna break out and we're gonna return true. Why are we gonna return true? Because all the checks were passed and we have got a palindrome text. So this thing is gonna not execute in the last iteration. This thing is not gonna be executed since we are breaking out of this while loop. But if it is not breaking out of the while loop, we're gonna execute the statement. Okay. If both of the characters are alphanumeric, this thing is gonna be skipped, right? If this thing is gonna be skipped, this thing is again gonna be skipped, and the first or second iterations if the text is short. And if s dot lower, if the particular pointer, whatever it is pointing over here, if the lower value over here, let's say, if the lower value over here, we're lowering the character over here and we're lowering the character over here. If both of them are same, if both of them are same, if both of them are same, Then we're gonna increment the pointer towards here, and we're gonna decrement the pointer towards here. But if we get in comma, special characters over here, like anything, then the right pointer is gonna stay over here, but the left pointer is gonna be incremented. Now we're gonna check again. Now we're gonna compare this value to this value. This value to this value is gonna be compared. Look at this over here again. If s of left dot lower, we're lowering it. Okay, we're lowering it. We're removing the sensitivity. We're lowering the s element. That is the left pointer, whatever the pointer of the left, what the left pointer is pointing towards, we're lowering it. And if they both of them are not equal, we're gonna return false. Since even if any element or any element of the string is not matching from the left and from the right, we're gonna return false. That's the thing, right? Or if it is not, if it is matching until it keeps matching, we're gonna keep incrementing the left pointer. I might keep decrementing the right pointer. And everything is done when each and every iteration is done. And when we reach to this statement that while left is equals to right and left is greater than the right, then we're gonna return true. Let's run our code. There's an error over here. Let me see. String has no object argument is ALUM. Oh, is I'm doing the same mistake. Is AL now. Okay. Now let's run our code. Okay. Case 1, case 2, case 3 accepted. Now let's submit our code. So hopefully you have got whatever I was trying to say. There were 3 ways of solving the same problem. And I think let's analyze the space and the time complexity, okay? The time complexity is O(n), where n is the length of the input string. That's true. The space complexity is O(1). The algorithm uses a fixed amount of extra space for the variables like left and right pointers, and no additional data structure proportional to the input size are used. Earlier, we were using O(n), but right now over here, with the help of 2 pointers, we have made it O(1). That is big O(1) notation, whatever you say. Okay. So that's it for this video. I'll see you in the next video. Until then, bye bye. Take care.